Cribl's innovation is its simplicity and its scale. Let me explain what that means. It's simple in the sense that it delivers immediate ROI. Customers get what it does right away and where it will fit. And it's scalable, which is its superpower. It allows for organizations for the first time ever to scale their data infrastructure in a manageable way.
At the foundation, the thing that really struck me about what makes Cribl so innovative is that they collect an enormous amount of data. They shape that data, they route it, they do it across infrastructure and security and applications. They can do it at a massive scale, and they can do it with low code or no code environments that getting all of that to work is incredibly difficult.
Cribl really empowers organizations to route their data to whatever place is best to store it and whatever place is best to analyze it. That's the sort of freedom that people just haven't had with machine data or with observability in the past.
Investing is very personal. We see so many opportunities and there are plenty of good ideas, great ideas. The team is brilliant. And to a person, people reminded me of that, customers, vendors, etc., competitors. And then I watched former colleagues join the company also, and it just gave it it gave it like the personal fabric that I felt like this was a group that I wanted to be in business for a really long time.
What convinced us to invest in Cribl was the right team, the right product at the right time, addressing the right market opportunity.
The team is really what got us most excited. I mean, in the end, as venture investors, we're investing in a group of people that we think have a chance to do something really disruptive. And when we had a chance to meet the founding team and the management team that they had built, we were convinced that this was a really special opportunity.
I think Cribl is going to be a new strategic layer in the data stack. It's as simple as that.
The process of getting into Cribl as an investor in 2021 was not for the faint of heart, which I interpret as, supply and demand. If more people want to be involved with the company than are allowed, it suggests to me that they're onto something.
We're honored to be partnering with the team at Cribl and are huge believers in the value that they can create for enterprise customers of all sizes, and we look forward to the journey ahead.
Cribl is one of the fastest growing companies we've ever seen in the enterprise space, so that growth alone was something that was really exciting to us.
At Sequoia, we like to say if data is the new oil, then Cribl is the new pipeline.
I believe Cribl has the opportunity to be one of the largest software companies of our generation. The market is enormous, the product works magically, and we're winning.
And we are live.
All
This
right.
is the first edition of Cribl TV. It's very exciting. This is Ed Bailey with Nick Hudecker. How are you doing,
Hey,
Nick?
I'm doing well. How are you?
It's great. It's amazing seeing the video. It's such a wide variety of investors who I think they see the vision of what Cribl's doing.
And they certainly know the space, right? They're longtime investors, longtime VCs, and it's interesting that they were talking about so many of the ways that we scale with Logstream, and we're going to talk about something that doesn't scale today. We're going to talk about syslog.
Yeah, it's going to be a fun conversation. It's almost like you want to ask yourself, tell me how old you are without telling me how old you are. Let's talk about syslog.
Yeah, this is something. So syslog's been around for what? I mean, nearly 40 years.
Yeah, the RFC dates back to the 70s, and it's there's two RFCs. I joke about so many things people call syslog aren't actually syslog. I mean, there's standards, there's well-established standards, been there forever, and that's some of the things we're going to talk about. Is that and that's from an observability point of view, security. That formats matter, timestamps matter. You need to know where your data is, where it was located, the who, the what, and the where. But without adhering to formats, man, it's a problem. And so we're talking about how you overcome those. I'm going to say fairly generic and high level. Then we'll talk about some tooling options of how to handle this. But it's still a challenge. It's a challenge of the modern data center space. And let's go into the presentation.
All right, take it away.
All right. Scaling syslog, the challenge that will never die. It will never go away. So we'll start off with what is syslog. It's it's syslog standard logging protocol. It's how you get telemetry data for a wide variety of things into your observability platforms. Giving you an example of what should be an example for an event. It can be very high volume data source and present significant challenges to modern observability teams.
So earlier you said that, and maybe I'm setting you up for some of your later slides, You said that people call things syslog that aren't syslog. So if it's a standard, and I know standards are always double-edged swords, if it's a standard, what makes it a standard, or what makes it so challenging? I mean, how many different standards are there?
Well, there's just two, but the thing is that you have every vendor in the world uses them, and let's just start with this example. See, at the very first of the event, there's an excellent timestamp. It's a high velocity, high precision timestamp that also includes the time zone. For global companies, you're going to have network devices all over the world in every time zone imaginable. Ideally, you would be in UTC, so that way time zones don't matter, but you almost never see that. And so you need your timestamp to reflect the location of the device. And just for simple things, and that when you like, if I'm in the Eastern time zone and I'm running a query, I need my tool to account that this device is in Indian Standard Time. Because I mean, if you think about it, if you say give me the time between 3 and 4 o'clock yesterday, 3 and 4 o'clock yesterday means something entirely different if you're looking at things in another part of the world. Mm-hmm. It can get extraordinarily confusing. Remember one time we had something happen, and it was incredibly puzzling. The developer team had hard coded the time zone into an application, so that application, no matter where it was in the entire world, said it was in Central Standard Time. And so we started deploying this application in India, South Africa, everywhere, and people came to me and was like, Splunk's broken, something's wrong with Splunk. And then the thing I always look for was, is it exactly 1 hour off, or is it exactly 3 hours off? Because if it was 3 hours and 2 seconds or 3 hours and 2 minutes, it's something else. There's always time zones when it was exactly that. But those are the things people don't think about until they run into them. And it's something you mostly see in global companies, because you're trying to manage your entire infrastructure from somewhere else. So the advice is, if you can do UTC, that's great. Most places can't. If not, you either have to log the time zone, and that's the example. This is a beautiful example of what a timestamp should be. Or what you have to do is you have to hard code that this source is in this time zone for every single one of your network devices. I mean, it's the only way to do it.
This isn't like a big company problem though anymore. I mean, with IoT, you could have devices everywhere, even as a smaller firm, right? You could have sensors on trucks that are rolling, on trains, planes, you name it. So this is a much bigger challenge, I think.
I agree. This is something like, for example, a friend of mine runs a really big logistics company. They have sensors in every one of their trucks, and every one of their drivers has an iPhone app. And it's for purposes of tracking, because they need to be able to know where is my pallet. That's always what they're asking. They have, and there's sensor devices in every single pallet, so that when they bring it into a warehouse, they can easily look. Here's my pallet. Here's how it has to get here. Very close to, for example, like with UPS. And it's a great point of how there's more data than ever. You need lightweight protocols, and that's what syslog is. It's a lightweight protocol for small scale devices to give you telemetry, and you need that accuracy, because, for example, think about the time zone offset. All of a sudden, your package that you think is in Central Time Zone, because the time zone offset's not set correctly, it could be somewhere else, and so it creates chaos.
Got it.
I think this from a telemetry perspective, the timestamp is probably the most important bit of data in the entire event, because if you can't place the event in the appropriate place and time, and then it's just not worth a whole lot. You see,
Agreed.
certain tools will ignore the timestamp, and they'll read the timestamp on ingest, essentially, which has its issues that we've already discussed, and there's others that'll try to read it, and that's why I think it's important to measure, control, and plan for your time, because it's such an important thing. And I think we have quite a few articles on the Cribl blog at cribl.io/blogs. David Maisel has written a couple of really good articles about timestamping, and I would recommend it for anybody.
If you've ever written code, right, of any significance, like you have an opinion on timestamps.
A lot of it for me with previous was yelling at people about timestamps matter.
Right. Agreed.
There's another thing. I mean, so you see that, what I call a high precision timestamp, because it goes into nanoseconds. So think about, as you talked about 40 years ago, you didn't have a whole lot of events per second. It wasn't, having tens of thousands of events per second wasn't something that most people dealt with. Now it's perfectly common in a transaction environment, and you need to know where that data is placed within the second. So you need that time zone to be a high fidelity timestamp. But too many devices just simply don't support that.
All right. So how do we get over some of these challenges then? Oh,
go to cloud.
My use cases.
All
right.
Yeah, but for everybody, you go to cloud. But for everybody else, let's talk about some of the widely used use cases. Firewall monitoring, support operations and security. Probably the single highest volume. You see companies that'll into the millions of events per second coming off their firewalls. They need to be able to separate the signal from the noise. They need to be able to understand state. They need to be able to understand who's coming through our perimeter, what data is going out through the perimeter, and so you have to be able to consume this data and not drop it. And we'll talk later about that dropping activity. Network device monitoring, another big thing. All your routers, all your devices, your Internet of Things use cases, those are all telemetry that's coming in from your devices. We in my last life, we had a couple thousand devices that were logging, as prosaic as TVs that were in the lobby, audio visual tools that were in the conference rooms. I mean, everything produced some sort of data.
Why are you storing that stuff? Out of curiosity.
Well, I mean, it's those things get compromised, and those and you want to know what they're doing, how they've been accessed, firmware versions, different things like that. Are they working? Was a big deal. You'd be surprised how many, for example, think about cameras, video conference cameras, things like that are completely open. They have no security on them whatsoever. And so you need to be able to know they're there. You need to be able to secure them. And the idea is just getting telemetry.
Got it. So more data.
Yeah, exactly. I mean, hey, if you're in the observability space, more data is a good thing. Open systems logging, that's crucial. And you're in the open systems world. There's a syslog daemon that's sending data on every single one of these servers. It's going back to the 60s. If it's any type of Unix, Linux system, it's emitting data through syslog. So either you have to put some sort of log shipper on the server or use the default metrics. But that's going to be the most common way to get operational security data off that system and into your framework.
All right.
Storage, device monitoring. That's a massive source of data, especially now with security requirements. One of the things that worked on before it was shocking how much data like an Isilon would emit, because every one of the companies trying to use the Isilon for NFS is for file services, for example. And so it'd be emitting who's accessing what storage, who's accessing which blocks. So there's a massive security use case for storage monitoring. And it was an enormous amount of data. Appliance monitoring with focused security tools. Security vendors love to deliver a closed appliance that is hard to use and that emits minimal data, or emits just a data that doesn't make any sense. That's always my favorite. When essentially I explain to a vendor, it's like your device is not emitting syslog, it's emitting a vomit of data over a port. That's not the same thing. And so those creates lots of challenges. I mean, we see the security devices that will use Ceph, for example. They'll use pipe delimited formats but call it syslog. And so those are all the kind of things as a logging administrator, you have to be able to pull in all this data and make it useful. And I think that's the critical thing is in the industry, we spend so much time on how do we get the data that we start leaving out, how do we make the data useful? And I think that's a big part as we talk about bringing Cribl Logstream into the mix, that saving time on getting the data in gives you time to make the data valuable. Here's how you turn this data into a business asset. And I think that's just an overlooked reality in the logging space.
And you're talking about the different things people will call syslog, right? In recent guidance from the federal government, right? They're requiring all of their offices and organizations and whatnot comply with some kind of standard for timestamps, just so they can better share and understand log data. So I think this is an acute problem, right? That's really not going to go away anytime soon. I think people are really starting to appreciate the scale of the challenge, though.
I hope so. It's mind-numbing. how many times you run into these problems, especially when you're looking at something like a security or an operational use case where time matters, that you have accurate data, that you have accurate timestamps and accurate data is just as important. And I'm glad to see the federal standards, and I hope those kind of federal standards will cascade down into the heavy industry, energy, pipeline industry, banking and finance, because it's something that's well overdue.
I think that what I think will happen next is the SEC will provide guidance or requirements around very similar type of a log maturity model for any publicly traded company. I think that's just with all the breaches that we've had recently with SolarWinds and Microsoft, Exchange. I think it's past due for those types of requirements. But yeah, let's keep going.
Absolutely. So let's talk about challenges with scaling syslog. This is the number one issue in a high volume environment. Being able to consume the data, being able to get it into your logging systems, and not drop the data is an enormous challenge. This is something I ran into when I first entered the last company. This was 15 years ago. We're looking at an environment where it took me a minute to figure this out, but that the security team was dropping about half of their data. They were missing about half of their syslog data because they simply hadn't thought through the scaling challenges of taking in syslog, and it created an enormous gap in security. And so then we had to go through these steps of how do we scale, how do we address these issues. And this is something I encourage anyone to do. That's very important to validate, and look at your source. Take your top 5 firewalls. You can get one of your network admins to give you the counter of here's how much data we put out in the past hour, and then look in your systems and see if it matches. And if it's within 1%, you're doing a really good job. Most companies, if they're going to validate, you're going to find something that's going to be disappointing. And so it's just you always got to keep validating. So let's talk about reasons for this. So UDP protocol is the basis for syslog. UDP is a stateless, sessionless protocol. The network device fires out the data and then it forgets it ever happened again, as opposed to a TCP connection where it's going to see, is the destination present, is the port present, will it accept my data, and then it'll send the data. The reason why network devices, and it's just so popular to use UDP, is it's a very lightweight protocol. When you're sending in hundreds of thousands of events over the network, these network devices simply don't have the hardware in order to sustain the overhead of TCP, much less SSL. And it's important to understand. There's a lot of jokes about UDP means and I forgot what it meant, because it's the nature of the beast, and you got to understand it. Mm-hmm. Does that make sense in terms of the dangers between not having a session acknowledgement, not having state, where does that make sense to you, Nick?
No, totally. It absolutely does. I would think that since you're using a stateless protocol for sending syslog data, that would actually make scaling a little easier. Certainly you don't have the guarantees, but because you don't have the overhead of state, it should make receiving or sending and receiving more data a little bit easier.
Well, then that's where we get to talk about load balancers, because that's how load balancers track how they load balances through state. So that's where that challenge comes in. Once you get to a certain amount of data where you're sending more data to a server than it can accept, you have to then load balance. You have to be able to spread your load, so not only for scale, but also for high availability. You have to plan for failure. And that's where in a modern environment, it's important to have some sort of load balancer in place. And you hit the nail on the head in terms of it should help. But once you get to that certain scale, you need load balancers.
Okay.
Lack of compliance with RFCs, another big issue. Let's just go into that in terms of when you're asking your Splunks, your Elastics, your Exabeams, your searching and logging tools to read the data, then you're going to have to write custom parsers for every single one of your potential syslog formats. Some of your tools are much more strict about that. It can cause and create a lot of overhead for your observability team. Imagine every single possible variation of your event you're going to have to write a parser for. And it creates issues for what you have to maintain and how to support it. High volume. I've seen some extraordinary amounts of data coming out of systems. I've seen, for example, we had this was years ago, but we had a firewall cluster fail. It went into a high CPU state and the whole thing got hung. It went to about 10x of its normal volume. This firewall cluster was putting out about 2 gigs per second of data, and it completely crushed my logging system. And that's where, I mean, 2 gigs per second of one type of protocol. I mean, the systems were like, oh boy, we can't handle this. Right. And that's where you get to, and that's from a planning perspective is, and this is something I encourage anyone with any kind of logging system, plan for your spikes, plan from a capacity standpoint for your worst case, because your average utilization of my daily of 100,000 events is not going to sustain it when you go to 2 or 3 million. Your systems are going to fall over. And that was a big lesson for me early on, that we had to work with the capacity teams to get them to understand that we need to scale our systems for the worst case, because that's when you need them to succeed the most. For example, you're a breach, someone has ransomware, everything's going bad, everything's emitting more data than ever. And you have to make sure you have the systems and the capacity in place to handle that. I kind of
that's a tough conversation to have with like your CFO, right?
Absolutely.
Like they're looking to manage those costs. Maybe this is something we talk about on a future stream, right? How do you make that justification to your CFO, that worst case story, right? They're very accustomed to optimizing for the common case, but handling those outliers, that gets really expensive. That turns into a very high cost conversation.
We ended up having to bring the CISO in play because we had to talk about risk. We need our telemetry systems to work when things are going the worst. And the only way to do that is to have that appropriate scale. Now with AWS and Azure auto scaling, that process gets a little bit easier. But even then, imagine you have a large on-prem system logging to cloud. All of a sudden, instead of 1 gig of data or 100 megs of data per second, you're now sending 2 gigs of data over. Then that creates your additional capacity concerns that you have to address. And it's such a hard conversation because people simply aren't thinking about, when things go bad, what do we do, and what do we need to work?
Yeah, it's understandable.
Modern network architectures are something to want to go into. Everyone loves to talk about segmented architecture and zero trust. For every hop, every firewall you ask UDP to hop across, you risk data loss. You risk issues with losing your data. You risk issues with also just capacity issues as well. That's something that people have to discuss. How do you ensure data delivery as much as humanly possible while still complying with your zero trust frameworks? And then family, security, lack of SSL. You cannot encrypt UDP packets. That typically has a lot of hard conversations with security folks. And then you then have to discuss the inability for the vast majority of syslog use case devices that emit syslog to use TCP, much less syslog. This is something, again, where we had this conversation. We had a new security architect, and I was like, sure, let's do this. So we went to one of the Cisco firewalls, and we turned on TCP and we turned on TLS. The Cisco firewall shut down because it got too hot. It had to use so much CPU in order to support this. It shut down. And,
wow.
And so and that's just that overhead. These systems simply are not designed for TCP, much less being in TLS. It shouldn't be this way, but it's the fact of dealing with these systems. Newer systems are better at this, but you think about, they're typically embedded systems. So like you look at your Cisco's, your network devices, your load balancers, you're looking at your storage devices. These are teeny tiny little OSs that have been optimized to perform a function. And typically they lack the ability to scale to deliver good SSL. I will never forget that we had to replace the device. It ended up having to be replaced because it was compromised that badly. And those are yeah.
That's staggering, man.
Yeah. I mean, it was
just a smoking husk of what it used to be.
Yeah, but I get it though. You have these little teeny tiny OSs, and there's a reason why the vendors say you need to use UDP, and also from a load balancing standpoint, that's a good reason too.
We've got a question from. Sorry, I didn't mean to interrupt you.
Good.
We got a question from YouTube. Are we recording this? I think we are.
I hope so.
Yeah, I believe we are recording this, and if you want to watch it again or share it, we'll definitely work on getting that recording posted.
And this is something I want to mention to everyone. This is our first broadcast of Cribl TV. We are going to be agile. We are going to iterate. We will get better.
Yeah. In case you couldn't tell, this is our first one. But so far, it's a lot of fun.
Yeah, this is awesome. It's one thing I would mention to everyone. We have a great Slack community, cribl.io/community. We have an amazing community leader, Pi, named Rachel. She's great. There's so many people to help you solve problems and have these discussions. Of how do you scale syslog. Nick and I are both in the community. Please reach out. Let us know how we can help.
Yeah, definitely. I want to echo that. All right, let's keep talking about our syslog challenges here.
So let's talk about a little about network architecture. So have a pretty typical diagram of segmentation of switches and routers, and you can see, so one of these devices has to then flow through network device to potentially to get over to the syslog server over here. Every one of these hops creates overhead. Every one of these hops creates risk of data loss. And this is an example of that thing of the kind of, I just want to get that visual of distance traveled, because we're not testing is the destination there with UDP.
Mm-hmm.
Theoretically, this should work fine, but I've seen plenty of use cases where routers and switches started having CPU issues, and the first thing they drop is syslog, where data's gone, and the data's gone forever. There's no retries, and so this is the kind of, but this is typical though. So many companies will have they'll have wide network segmentation. Then they'll have what's called a network management VLAN, where they'll have trunks into all of their firewalls to get to that network management VLAN. But you're having to transit a lot of devices to get there. The things that I recommend people consider doing are putting bypasses in your firewall. I mean, do you really need to have have complete firewall coverage for your network syslog? I mean, this is something we have run into many times, where you can see a device logging back to the network monitoring system, and you'll see it hit multiple firewalls because every hop hit another firewall. Is that really necessary to be able to record that activity? Because if you can put bypasses, it's less overhead, and that's less overhead on your firewalls. It's less potential drops for your data. Another thing I recommend. Yeah, and those are the kind of things that or what you do is you have all of your network devices are essentially on the same VLAN. That does create some risk, because you put your network monitoring right on the same VLAN with your network devices, and that's another option. But it does have some risk, because if that VLAN is ever compromised, then you got a problem, because you have somebody loose on a network with not a lot of controls. But it's a conversation you want to have with your security team, because these are important principles of security and of segmentation. You have to find the right balance and work with your security teams to work these things out.
Yeah.
One of the things I want to mention, another way to do this, and so is to have the syslog server that I've drawn here, is you have this in each segment. So you have a syslog server here, you have a syslog server over here, you have a syslog server over here, and it's a lot of syslog servers, but what it does is it gives you the ability to collect data as close to the source as possible. So hopefully you're using Logstream as your syslog server. So by having Logstream as close to the source as possible, you go UDP to Logstream, and then Logstream is able to then turn around and then deliver the data to Splunk or Elastic in TCP. So you get that best mixture of UDP delivery, you're close to the source, and then you get TCP delivery. So because that TCP delivery is going to be guaranteed. Logstream, for example, is going to have queuing, so that, for example, if your destination does go down, Logstream is going to queue. It's going to write that data to the file system until it comes back up, and then it's going to retransmit. And it's a great way to compensate for the limitations on these devices. Is that making sense in terms of compensation?
No, definitely. We should mention what Logstream is. Logstream is Cribl's flagship product today, and it's an observability pipeline that sits between the sources and destinations of all of your observability data. And so it helps you route that data. It helps you We're getting a bunch of responses from Cribl saying yes. Oh, that's about the recording.
Yeah,
Sorry. Good that we're responding. And so what Logstream does by sitting between those sources and destinations is it lets you route that data to multiple locations. You can trim out data that you don't need to send on to your destination. Like if you're like most organizations, you're probably at your maximum budget for your Splunk or Elastic or whatever cluster you're working with. So being able to kind of economize on that data is a big win for a lot of our customers. You can also enrich it, add new information to that stream as it passes through in flight. You can redact PII. So it really gives you a lot more control over what you're sending onto those destination systems and in what condition it shows up in. So that's just our summary real quick on Logstream. We're going to talk about it more later, but I wanted to, since Ed's brought it up, I want to talk about it and just mention it now.
Yeah, that's a great summary. Another advantage for Logstream is you're able to, because you're having Logstream or your network device, your syslog receiver in every segment, you're going to have a lot more of them. And that creates challenges when you're using open source like our syslog or syslog ng. Is how do you manage all these instances? Where Logstream makes it very easy to be able to push down simple rules to your workers that are in every segment. So saving, and that's very important for me. I've spent a lifetime managing these devices, and being able to make this process simpler and guarantee delivery is my aim. That's that value of being able to having assurance monitoring and making it simple. It's so important to be able to deliver that to our user community.
Yeah, definitely. All right, let's keep moving.
Right. And I'm going, oops, hold on.
Go the wrong direction.
There we go. Okay. So syslog is almost never syslog. So I'm posting a screenshot from the vendor that almost invented syslog of how its own syslog is not RFC compliant. The comments that are in this ticket are hysterical. I recommend anyone could look this up in the Cisco comment section for this ticket, because it talks about they're not following their own standard, the standard that one of their guys wrote. And just to show you from an example, this host name should be here, and you look at the actual current, it's just a timestamp. There's no host name. And so think about it, it's just an IP address. This is very common. So it's one thing to point out that you can have network devices that can have hundreds of IP addresses. Having an IP address there is not a good identifier. Mm-hmm. You need to have the host name, and you need to be able to follow the standards. And this is just an example. It's a simple example. I've seen other there's a API gateway that drove me crazy for a long time, where you couldn't set the host name on the event, so you had no idea where it was coming from. We had 60 odd of these events, and we had a hard code in Splunk. We had to have a hard coded lookup of if it's coming from this source, we were able to understand that it's this host name, and it drove me crazy.
I think companies get this wrong when they're not consuming their own data. If I'm not, I don't care what the format is. If I'm not using it, I'm just sending it out. It's somebody else's problem after I send it out. So it shows a real lack of empathy, I think, on the part of the vendors.
My hair is this gray because of this kind of crap. And this is for example, some of the other iOS it mismatches. So you'll have the timestamp come first, you'll have the host name come first, you have the device name. It's a continuing conversation with network admins about standards, and this is the kind of thing that it's an unceasing conversation. But the way I look at it now is we have to arm our admins with the ability to adjust, because true standardization is not going to happen.
No, it's not. It might change from version to version for the same device. So you've always got to be ready.
Yes. And this, how do we give our users the ability to adjust, the ability to not want to start yelling at people?
Not yelling is good.
So this is what we spoke about load balancing. So I just want to have a kind of discussion of typical TCP load balancing behavior. TCP has session and state, where the source and destination see each other, they acknowledge each other, they send data. And from a load balancing perspective, it's great because you're able to map source and dest, you're able to map the flow, and it's very clear when something starts and when something stops. And I thought this was a really great diagram for that. It's how you can see top line device, top line, and then they'll load balance as they need.
Got it.
So UDP, not so much. UDP, because there is no session and there is no state, it's just fire and forget. Data comes, load balancer then tries to place it. This is where you get in trouble, because where things can get really troublesome. You have very uneven distributions of data. Very uneven distributions of data, where typically you want to think on a load balancer that, okay, I have 1 gig per second. I can split my load up evenly across 5 servers. And so it's 200 megs per second over 5 servers, and that's something I can sustain.
Mhm.
Because of the way UDP works, you can't get that. You're going to have wild swings in level of data. You see where on a second-to-second basis, you'll see 50% of your data on one server. And so this is where having better load balancers really helps. Having F5 admins who know what they're doing really helps, because they'll put in iRules in order to force the data to have more of an even spread. But with high load and also limitations on load balancers, there's only so much they can do.
Mm-hmm.
So that's why it's important to not use simplistic planning. Where the way I would look at it is like, if I'm looking at 1 gig per second, I'm going to double that. So I want to scale for 400 megs per second for each server in order to make sure that I have that 50% overhead, as we talked about before, to be able to scale.
That's actually 100% overhead.
Yeah,
right?
and I think, I think that's very important. A couple of things I also wanted to mention. Very, very, very few UDP devices support DNS. So you're not going to be able to use DNS load balancers. You're not going to be able to use DNS failover.
That's a really interesting point that I hadn't considered.
Right.
The DNS aspect of this. That's vital.
So think about, you have multiple data centers and you have some sort of outage. So your load balancers go down, and then in most places, dealing with TCP logging, you're going to be able to fail over to your other data center. So if I had Elastic Beats or a Splunk Universal Forwarder on a server, I'm going to be able to load all of my data receivers and all of my data centers. And so if data center 1 goes down, they're not going to care. They're going to move on to data centers 2 and 3. That's not possible with the network devices. Because the network devices, and it's because of the load. Imagine if I'm sending 100,000 events per second and I have to do a DNS lookup for every one, that's going to crush your DNS servers. And so that's the reason why they don't do that. And the DNS admins are glad. But that is from a planning for failure standpoint. And this is another argument for putting your receivers as close as possible. So by putting Logstream in the same network segment with your network devices, that's going to give you the ability to fail over if you have a massive outage in one of your data centers, because you can load multiple destinations in the log stream, and that will be DNS aware, but you can't do that with the network devices.
Okay. No, I think that makes sense. That's good input.
So when you have some, and this is where putting your data as close to your devices is super important, and it does make for a lot of devices. But I think this have that visual of getting it as close as possible, and then you can then send your data on as you need to. But also work with your network architects, work with your security architects, because typically they're going to be working against each other. Of how do you fit your data in? Because everyone wants the same thing. The security architects want data delivery, the network architects want data delivery, but how do you achieve it? And that's where it's super important to do these things. And I had a thought, but all right. So get your devices as close as possible to the sources to give you that flexibility for delivery.
No, I think it's a good plan. We're seeing that more and more. I think as companies go kind of hybrid cloud, right? Some stuff is happening in a chosen cloud provider or multiple, but they're always going to have some stuff on-prem, I think in 99% of the cases. And so being able to have the processing or the data direct, as close as possible makes a lot of sense from an economics perspective.
Yep. And this also in terms of that. So this is another concern I see constantly is I have network devices now that are in AWS that are going to have very structured, very clean data. I'm going to have VPC flow logs, but I'm also going to have syslog. How do I mix this data in order to have an end-to-end flow? Think about if I'm talking cloud down to on-prem or on-prem to cloud, how am I able to trace this? And this is another thing that let's I think we should make this probably our next broadcast of how do we take different structures of data? So you have unstructured data like syslog, you have highly structured data like VPC flow logs, where using a good analytics product, you're going to be able to have that end-to-end trace. And I think that's another good example about Logstream. By being close is going to give you delivery. It's also going to be able to give you the ability to put fields, to put structure, essentially turn that syslog into structured data. So with some smart queries, you can have that end-to-end view that you wouldn't ordinarily have.
Right.
So just closing notes and considerations. Work with your admins to have consistent formats. Have the conversation with your network engineers and your storage engineers and your open systems engineers over and over and over again until either they quit or you quit. But someone has to win in order to have consistent formats.
Well, I mean, so let's unpack that a little bit, right? I mean, how do you get all these parties on the same page, right? Like why, you mentioned that network and security admins are at odds in an organization. How do you get them to be incentivized together?
And that's a very fair question. It's not easy. It's organizational. Companies really have to look at alignment and incentives of how do we get ourselves in a position to succeed, because otherwise it's individual contributors flailing into the wind and trying to use personal relationships to do what should be an organizational standard. And so it's important that if you're that observability architect, that you write down. So you work with the teams and write down your standards. But then you have to have the accountability mechanism of so and so hasn't, so and so doesn't have, is not compliant. So we gotta work with our global risk and compliance, so their GRC teams, of how do you understand, I'm sorry, governance, risk, and compliance, of how do you document this, and as an organization hold these teams accountable. And that's why I think data governance is an important subject. If you're in the observability space, if you're working in security data, make friends with your data governance teams to help you get visibility from a compliance standpoint that your formats are out of whack. It seems like a minor thing, but it really matters. The downstream effects are significant.
And we've seen like mismatched incentives all over the place. I think especially as the observability conversation matures, right? So much of the observability focus, I still have trouble getting that word out regularly. But my cat's coming into my office and she's demanding attention. But so much great for the live stream, right? But so much of the focus for observability has been on DevOps, but most of the benefits are going to accrue to the operations teams. And so,
Security.
yeah, and security, right? I kind of lump security under operations, right?
Yep.
Day to day blocking and tackling, keeping the lights on. And I feel like there's this huge incentive mismatch between all these different parties that has to get resolved if we really want to do something interesting and meaningful with observability going forward.
I couldn't agree more. And I really wish that this is something that I mean, we try every day, but that the conversation about observability is about everybody. Anyone who needs to monitor anything in the environment needs visibility. You need to be able to ask questions of what I don't know in order to drive your proactive monitoring, in order to drive everything. And that's operational and security.
Yeah.
And it starts with good data. And good data starts with good formats. So not only with application formats, but your syslog formats, because just quality data, the telemetry drives the insights.
No, it's a good point. All right, let's wrap it up.
All right, so just real quick, load balancing your traffic. One thing I want to emphasize, and this is something I've seen in a lot of conversations, I've seen certain individuals who want to talk about the one way to load balance syslog. One thing I would communicate to everyone that that the one way is what your environment can support. Don't do IP multicast load balancing if your network and VMware teams don't have the skill set to support it. Do what your environment can support. Like for me, I'm not going to be on your bridge if you have a problem, if you try something you can't support. So make sure you're doing it, but put that effort into getting load balancing in place. Put your syslog receivers as close as possible to your logging sources. Hopefully that's going to be Logstream. Understand the impact of firewalls and network hops to UDP. You want to make sure that UDP data travels as short as possible distance to the receivers. And then also, finally, have options to clean up, fix, improve, and reduce your data, such as Cribl Logstream. And I think that with those steps, with that kind of focus, you can scale your syslog too. And then you'll have gray hair like me.
For those of you watching, Ed's only 24 years old. This is what being in security and operations will do to you. No, this is incredibly informative.
Do we have any questions? Anyone have any questions in the chat?
Yeah, we're live on like 3 different platforms now. So any questions, happy to field them.
And if not, we're both available on Twitter. I'm eBailey 1367. And Nick, what's your handle?
N Hudecker. So NHEUDECKER. Pretty easy to find. And we're also both on the, as Ed mentioned, we're both on the Cribl community.
And also LinkedIn.
So if you want to try this stuff out, if you want to try Logstream today, you've got some great options. You can go to sandbox.cribl.io and you can go through kind of a guided tutorial of the whole process. If you want to sign up for a cloud account, you can go to cribl.cloud and use Logstream. You can process up to 1 terabyte a day for free. You don't have to talk to anybody. There's no request a demo button on the website. You just get to use the bits. And if you do that, let us know what you think. Always happy to get some feedback. And if we can help with anything, as Ed mentioned, don't hesitate to reach out.
Yep, I think that's it. Thank you very much. Thank you very much for your time. I appreciate it. Great conversation.
Yeah, great. Thanks, Ed.
All right. Thank you. Take care, everyone.